Hi, this is Alex from devstories.eu. PySpark Fundamentals, episode 21 of 21. Debugging distributed Python code usually means digging through thousands of lines of meaningless Java errors, trying to guess why your function failed or why it consumed all the memory on your cluster. You no longer have to guess. Today, we're looking at profiling PySpark's memory and performance, along with simplifying stock traces. When you write a user-defined function, or UDF, in PySpark, your Python code runs on top of a Java virtual machine infrastructure. If your Python code divides by 0 or references a missing dictionary key, that simple Python exception gets swallowed. It is passed back through the PySpark daemon, across the network, and wrapped in massive Java exceptions. Finding the actual Python error in your logs is tedious. You can fix this by enabling simplified tracebacks. When you set the Spark configuration for simplified traceback to true, PySpark changes how it reports errors. It strips away all the Java interoperability logs and worker process noise. The next time a UDF fails, your console will output a standard, clean Python stack trace showing the exact line number in your Python file where the exception occurred. Fixing crashes is only half the battle. Fixing slow or memory-hungry code is much harder. If you write a pandas UDF that processes millions of rows, it might run successfully but take far too long or trigger out-of-memory errors on your executor nodes. Historically, finding the bottleneck required adding manual logging or guessing which pandas operation was inefficient. Spark 4.0 changes this by introducing built-in Python UDF profilers. Here is the key insight. You can now profile your distributed Python code line by line directly within PySpark. To use this, you set the UDF profiler configuration to one of two modes, performance or memory. If you set the profiler configuration to the word perf, Spark activates the performance profiler. You then run your Spark job as normal. As the worker nodes execute your pandas UDF, Spark tracks the execution time of every single line of your Python function. Once your job finishes, you call the show method on the Spark profile object. Spark will print a detailed report to your console. For every line of your code, you will see exactly how many times it was called and the total time spent executing it. You can instantly see if a specific string manipulation or mathematical operation is slowing down your entire pipeline. If you're dealing with memory limits, you set the UDF profiler configuration to the word memory instead. The workflow is exactly the same, but the output changes. When you view the profile report, Spark shows you the exact megabyte increment caused by each line of your Python code. You can see exactly where large arrays are being allocated and where memory is failing to release. This line-by-line visibility takes the guesswork out of optimizing complex data transformations. You can pinpoint the exact cause of your performance issues without leaving your PySpark environment. Since this is the final episode of our PySpark series, I encourage you to check out the official Spark documentation and try these debugging tools hands-on. If you have ideas for what technologies we should cover in our next series, drop by devstories.eu and let us know. Thanks for spending a few minutes with me. Until next time, take it easy.